Okay, now we officially move on to chapter 1. Okay, this is still a very basic chapter. I think things will start to get difficult from chapter 2 and chapter 3 actually, chapters 2 and 3. And then chapter 4 will be the usual stories, hypothesis testing, t-test, f-test that you actually have learned in your third year econometrics. Okay, so this is the first chapter. Okay, chapter 19 we already covered. Okay, virtually self-study, although I still gave a summary highlights video. Okay, outline for chapter 1. Okay, I'm sure you are familiar with most of the topics in this outline. You learned most of them in your second and third year econometrics. Okay, nature of econometrics, just to let you know. Okay, although econometrics is a highly quantitative module, it still involves theoretical thinking, so keep that in mind. And then the 4 typical goals of econometrics. Okay, let me stop for 30 seconds for you to go through the 4 bullets or the 4 goals, and then I will go back to the study guide and give you an example of each. Okay, so now let's go to the study guide. I think I can zoom that out a bit. Okay. First goal to estimate the relationship between the economic variables, and then I have an example. Consumption as a function of income, so we want to know the relationship between income and consumption. Most likely positive relationship because the higher the income, the higher the consumption. But I specifically want to focus on the marginal propensity to consume, which is your slope parameter. How small or how big it is. Although we already know the range of MPCs between 0 and 1. So this is the first goal. Estimate relationship between economic variables. Second goal of econometric analysis is to test economic theories and hypotheses. Okay, think of this example. Quantity of CD as a function of income. Would it be possible that nowadays the slope parameter has changed from positive to negative? In other words, the higher your income, the lower the quantity of CD purchased. So in other words, I want to know the usual theoretical thinking that CD is a normal good. Does it still hold now in the 21st century? Okay, in other words, I start to think that CD should nowadays be an inferior good because I think if you think about the youngsters, I think they no longer purchase CD. I think they will download MP3. Okay. So we want to challenge this theory, to be honest. Okay. Third one, forecasting. Okay. Then it involves time series data. So look at the regression investment as a function of interest rate. If interest rate would be 5% next year, then I substitute 5% into the regression. Then I can forecast or predict the estimated investment next year. Okay. Last one, evaluate policy. So let's look at this example. I use the annual data for 30 years, from 1990 to 2019, to run the probit regression. And by the way, probit regression, just to give you an idea, your y variable is binary, either 1 or 0. Okay, I repeat, the y variable of a probit is binary, either 1 or 0. So this is an employment probability probit. Okay, 1 would be yes, employed, 0 would be no, unemployed. So if I run this regression, employment probability, it means nationally the employment likelihood of the labor force or the job seekers is a function of the mean years of education of labor force. I think we expect a positive slope here because the more educated the labor force on average, the higher the employment probability. Remember, the labor market demands highly educated people. And then the other one is the Minimum Wage Act dummy, which started from 2002 actually. So this dummy will be equal to 1, would be 0 from 1990 to 2001, and when the act was official from 2002, then this dummy equals 1 from 2002 onwards all the way to 2019. Now I want to focus on the parameter of this variable, this explanatory variable. If the parameter of this minimum wage act dummy is negative and statistically significant, then it means that relates to this policy evaluation part. So does it imply the imposition of the minimum wages has a serious negative impact on the employment prospects of job seekers in this hypothetical country X. Okay, so this is the fourth purpose of conducting econometric analysis. Okay, then I can go back to the slides. It is about the A-step methodology and the error term. So let's go back to the slides. Okay, the nature of econometrics. I think you have seen this slide before in Eco 242, the three definitions of econometrics. And as I mentioned right at the beginning, econometrics, although involving math and statistics and data analysis a lot, and even the use of specialized data analysis software packages, it always involves economic theory or theoretical thinking. So keep that in mind. Okay, I think you have seen this graph before, okay, about the relationship between lecture attendance and third-year econometrics marks. Positive relationship, the difference between actual Y and predicted Y is your residual. When it comes to sample regression function, when you can only interview a sample of people. And then I think I can skip this part about the history of econometrics. When you have time, you can go through the next few slides. A-step methodology, I'm not going to go through all A steps actually. You already learned it from your Eco 242. Okay? The only thing I want to talk about is that if you luckily can interview the full population, the big N, then the difference between actual Y and the expected Y will be your U, which is your error term. Okay? An error term represents the factors that are not taken into account. In other words, error term actually includes the omitted explanatory variables. Okay. More on that in the next chapter. And then the data, 4 types of data, I will talk about that later. And then we use the regression. We use the OLS method to derive the regression parameters. Okay, this is an example. Consumption head equals 150 plus 0.75 income. So the interpretation of constant is 150 means if my x1 actually income is 0, then the regression predicts that on average we still spend 150 rand. I think it makes sense even if we don't earn any income, we still have to spend on some essential items like food for survival. Then you might wonder where would the money come from? Obviously from our own savings. And then the slope, which is marginal propensity to consume 0.75, then it means if income increases by 1 rand, then the regression predicts that on average consumption would increase by 75 cents. Okay, and then hypothesis testing, you should know the similar stories on the sample regression parameters to draw some conclusions on the population regression parameters. Okay, those t-test, f-test, and so forth. And then model specification, do we use the right functional form? Do we commit underfitting? Underfitting means we exclude relevant explanatory variables, while overfitting means we include irrelevant explanatory variables. Then we can use the regression for forecasting or policy evaluation purposes, which I have discussed earlier. And then there's an example here. Okay, let's look at this. Our spend in criminal activity is a function of 7 variables. I actually want to go back to the study guide. It is easier, okay, to go through that. Okay, why our spend in criminal activity is a function of, this is a multivariate regression. X1 is the wage in criminal activity, so we expect this slope to be positive. It means if we can earn a lot in the criminal activities, then we are going to spend more time in criminal activities. But actually, my question is for X1, wage of criminal activity. Is it really easy to obtain such data? I doubt. So I think in reality, when we run this regression, we are most unlikely be able to include X1 because it is so difficult to capture data on X1. Wage of criminal activities. I can't think of any institutions like Statistics South Africa that release data on wage of criminal activities. Okay, X2 is the wage for legal employment. Then the labor force survey does capture information on wage on formal labor employment. So I expect B2 to be negative because if we can earn more in the legal employment, then obviously we would spend less time on crime. Okay, why would we be so silly to commit crime if we already earn a lot in our legal employment? And then the next one, X3 would be the other income, maybe my investment income, etc. So if I earn a lot from other income sources other than work activities, then it means I actually have a lot of savings. Then why would I commit crime? Then obviously I would spend less time on crime, on criminal activity. So B3 would be negative. X4 is the probability that I will get caught if I commit crime. The higher this probability is, then the lower the time I would spend committing criminal activities, because I feel scared I will be caught. So B4 will be negative. And similarly, X5, the probability of being convicted, it means I have to go to jail. Okay, if caught, then the higher this probability, then the less time I would spend on criminal activities. So again, B5 would also be negative. And then B6, expected sentences. The longer the sentences is, it means I have to go to jail for 30 years. Then it will scare me off from committing crime. So B6 would be negative. And finally, X7 is age. That this is the uncertain one, because some would argue that the youngsters are more likely to commit crime due to reasons like youth unemployment, especially in South Africa. Youth unemployment is very high and very serious. But then the other side of the story is that maybe the elderly people, they are more skilled, more experienced, they have better tactics. Okay, they know how to commit crime. Than other people would argue the elderly people will spend more time on criminal activity. So the answer about the sign of the slope parameter of B7 is a question mark. We really don't know. Some argue it is positive, some argue it is negative. And finally, U stands for the error terms, the difference between actual y and the estimated y. Let's say this is a sample regression function. So error terms include other explanatory variables that are currently not included in this regression model, such as our moral character, family background, conscience, honesty. Okay. There could be certain reasons why we exclude these explanatory variables. For instance, how can we measure moral character? How can we measure and capture data on conscience and honesty? It's hard to quantify these information. This is the next one, which I would use in chapter 2 actually. Wage is a function of, currently I run it as a simple bivariate regression. Wage is a function of educational attainment. Okay. And most likely I commit underfitting, because I don't think educational attainment is the only explanatory variable that would explain variation in wage. So the error terms include the other omitted explanatory variables such as IQ level, experience, gender, productivity, etc. So next chapter we would focus a lot more on the error terms. So the argument is that this bivariate regression is regarded as reliable only if error terms are the mean of error terms is constant at different x1 values. So in other words, we have to argue that the mean of IQ, mean of experience, mean of gender, mean of productivity, it means the mean of all the omitted explanatory variables will be constant and the same at different x1 values. And I think it is unlikely to hold actually. And then later I would argue that there is actually some correlation between x1 and the error terms. That it means this regression, game over. I committed underfitting or omitted variable bias. Then it means, I think it makes sense when we run the regression on wage, we usually would include some gender dummy, productivity, years of experience, and so forth, and even provincial dummies. Okay, because remuneration in provinces like Western Cape and Gauteng might be a bit higher actually. Okay, slide number 19, reasons why the error terms would exist. Okay, that relates to a question we did 2 years ago, so I will explain it in the next video.